Welcome to the last organic chemistry lesson. This is all about the applications of organic chemistry. The first application we're going to talk about is hydrocarbon cracking. Fossil fuels are formed by natural processes like decomposition. And carbon, such as coals, are also classified as fossil fuels, and then petrol and natural gases as well. Fossil fuels are non-renewable. Therefore, we can use all our fossil fuels on Earth, and then there won't be anything left for energy, like coal for burning for electricity and petrol for vehicles and so forth. This is a natural process, fossil fuels, and it's non-renewable. Very important. Now, in hydrocarbon cracking, it's an important industrial process, and in this process we are breaking up long bulky alkanes into smaller compounds, which is shorter alkanes and alkenes. For example, let's look at dodecane. There's 12 carbons and it's an alkane, only single bonds. Now, if you do hydrocarbon cracking on dodecane, you'll get hexane, ethane, and butene and ethene. Now, very important, like if you do hydrocarbon cracking on icosane, which is 20 carbons, you get octane. And octane is used in fuels, propene and nonene. So this is an important industrial process where we can use long bulky alkanes and form molecules that can be used for energy purposes. There's two types of hydrocarbon cracking. The first type is thermal hydrocarbon cracking, which means it is occurring at a high temperature. And the second type of hydrocarbon cracking is catalytic, and then it is performed at a low temperature. Products are separated with fractional distillation. The second application for organic chemistry is the combustion of alkanes, and we also call it oxidation, since it's just the burning in the presence of oxygen. Alkanes is the most important fossil fuel. Combustion or burning of alkanes are exothermic, and that's where you get the heat from. The reaction is giving off heat and therefore energy. In combustion or burning of alkanes, that we also call oxidation, you get at the end only CO2, water, and energy, and it's that energy part that we are after. Here's an example. An alkane and oxygen gives you CO2, water, and energy. Let's look at methane. That is the most simple alkane, only one carbon. And if you burn that in oxygen, you get CO2, water, and energy. And then the same for all the other alkanes. The third application for organic chemistry is the production of esters. An alcohol plus a carboxylic acid gives you an ester. It is acid catalyzed condensation. We are going to stick two separate molecules together, like with Bostik at home. But we are also taking a part out, and the part that we are taking out is water. So in the production of esters, that we can also call esterification, we are pasting together an alcohol and a carboxylic acid. And this is acid catalyzed condensation. So here's your alcohol, the red molecule. And here you have your carboxylic acid. Here is the acid catalyst. Now we're going to paste the orange atoms to the red atoms. And we're going to give off water, which is the black ones. There's your OH and there's your hydrogen, giving you water at the end. and we are adding that carbonyl carbon to your oxygen from the alcohol, and then you get an ester. Here's another example. Here we have butanol, which means we've got 4 carbons and an OH. As well as propanoic acid, which means we've got 1, 2, 3 carbons and your acid moiety. Now we're going to stick them together to form the ester. You have your alcohol part, which is giving off a hydrogen atom, and you have your carboxylic part, which is giving off a hydroxy group. The hydroxy group and the hydrogen bonds to give you water, and your carbonyl carbon bonds to the alcohol oxygen to give you an ester. Now if you need to name this ester, you look at the part that's bonded to the oxygen, the alcohol part, and you'll see there's 4 carbons, therefore butyl. And then the carboxylic acid part is 1, 2, 3 carbons, and therefore propanoate. This reaction can also be written like this, where you all have the condensed structural formulas and water, or you have the words. So, draw the structure of the ester formed from hexanol and propanoic acid. Here is hexanol, 1, 2, 3, 4, 5, 6 carbons, and propanoic acid, 1, 2, 3 carbons and a hydroxy group. Now we're going to paste them together. That carbon to the oxygen of the alcohol, and we are taking out that hydrogen and the OH to give you water. So there you have it. Paste it together and the water on the side. Now if you have to name that ester, you'll have hexyl, because that's what's bonded to the oxygen, hexyl, and then 1, 2, 3 carbons, propanoate. Thank you.